Hello everyone, this is Mr. Appel, and today I'm going to continue with complex numbers with really a review from Algebra 2, but this is some stuff you may not have had as much experience with, or maybe you have. So let's get started. The first thing is what happens when we divide complex numbers, imaginary numbers. Well, really nothing special happens at this point. The only problem is you might be looking at this and saying, well, there's not really anything I can do. The only issue we have with this problem as it is the denominator is not rational. Remember that whenever we write fractions, we want the denominator to be rational. Hence the term, you may remember, rationalizing a denominator. Well, imaginary numbers are definitely not rational numbers. They're not even real numbers, so they certainly can't be rational numbers. Rational numbers being a subset of the real numbers. Rational numbers are one of many different groups of real numbers. Okay, so we have to rationalize the denominator. So we need to do something to the bottom to make it rational. And so for this one, I'm going to use a little trick, which is I'm going to remember back to the last lesson that when I multiply I by itself, I times I get I squared. And I squared actually becomes a rational number. It's just -1. So I'm going to use that fact to help me here. What I'm going to do is multiply the top and bottom by I. And so on the top, I have -3i. And on the bottom, I have 5i squared. But what's I squared? It's -1. So that denominator just becomes 5 times -1, which is -5. So I have -3i on the top, I have -5 on the bottom, and now my denominator is rational. Now I'd like to simplify that a little more. I've got negative on the top and bottom, so if I multiply the top and bottom by -1, it becomes +3i over 5. Generally don't want to leave it like that with negative on the top and bottom. It's just not as pretty as this. Okay, but wait, there's more. What do we do here? So here, multiplying top and bottom by I doesn't help us because we'd have to distribute the I and we'd end up with a 3i in the denominator, which would mean it's not rational yet. So we're going to use a little trick, not really a trick, but a mathematical technique. We're going to use the complex conjugate, it's called, the complex conjugate. And the complex conjugate, it's kind of like difference of squares, if you remember difference of squares. If you had an expression like 3 plus x and 3 minus x, that when you FOILed that, the outer terms and the inner terms would cancel out. So effectively what would happen is you'd multiply the 3 times 3, which is 9, the x times the -x, which is -x squared, and that's all you'd have. Those outer and inner terms would go away. So we're going to use that same strategy here. So 3 minus I is our denominator. What I'm going to do is I'm going to multiply the top and bottom by the complex conjugate, which is, again, it's basically just the same exact term, except we change the sign on the I. So instead of 3 minus I, it's 3 plus I. So I'm going to multiply top and bottom by 3 plus I. And watch what happens. I'm going to erase that to make a little room for me to work here. Watch what happens, though. So on the top, we get 6 times 3 is 18. 6 times I is 6i. On the bottom, though, something fun happens. We get the 3 times 3, which is 9. The outer and the inner are going to cancel out. We're going to have a plus 3i and a minus 3i. They cancel out, so those i's go away. And then the last, the -i times the positive I, that's a minus I squared. But you can do something with that. Okay? So on the top, I have 18 plus 6i. On the bottom, I squared is -1. So this becomes 9 minus -1, which is 9 plus 1, which is 10. Notice my denominator is now rational. No more i's in the denominator. Yay! But wait, there's more. You do still need to simplify that fraction. I notice there's 2 terms on the top, 1 on the bottom. I can heart it. And I can do that because they all have a common factor. In this case, that common factor is 2. So we divide everything by 2. So that becomes 9 plus 3i over 5. And that's that. Okay, moving on. Solving equations with complex solutions. So here's a simple example, because you'll notice there's no x term, and if you remember, when there's no x term, equations are much easier to solve if you notice that. So what I'm going to do is just move the 54 over, so this is going to become 9x squared equals negative 54. Oh, that's the cuckoo clock that Sophie got from her grandma a couple weeks ago, so sorry for that distraction. I don't know if you can even hear that. Anyway, divide both sides by 9, and we get x squared equals negative 6. And now I can take the square root of both sides, and I get x equals plus or minus, don't forget the plus or minus. I'm going to take the I out, so that becomes I rad 6. Can't simplify rad 6, so that's as good as it gets. But my solution then is plus or minus I rad 6. So basically the same thing you would have done, except that you're going to have an I in your answer. Now let's step it up a notch. Here's another example. This one, try to factor, can't do it, not factorable. So now we're going to do quadratic formula, or completing the square. So let's do quadratic formula, and we can do completing the square too if we have time. But let's try quadratic formula. Okay, so quadratic formula says it's negative b, so that's negative 1, plus or minus square root of b squared minus 4ac. I like to write it all out with parens so I don't mess things up. So b squared, b is 1. So that's 1 minus 4a, a is 1, times c. And then 2a, a again is 1. Okay, so now let's simplify and see what happens. So underneath the radical, 1 squared is 1. 4 times 1 times 1 is 4, so that's 1 minus 4. So that's a negative 3, and you see where this is going to go. Going to have a negative under the radical. We're going to have to do something with that. Denominator is 2, but I can't leave it like that. I've got to deal with that negative. So what I'm going to do is just negative 1 plus or minus I rad 3 all over 2. Look for a common factor to see if I can hard it. I can't, and so that would actually be your answer. That's all for now. Good luck.